Hi guys, let's solve today's Leetcode problem, and it is problem number 2452, words within two edits of dictionary. Let's read this out. So you're given two strings array queries and dictionary. All words in each array comprises of lowercase English letter and have the same length. Okay, in one edit, you can take uh, you can take word from queries and change any letter in that to any other letter. Find all words from queries such that after a maximum of two edit equal some from dictionary. Return a list of all word queries that match with some word from dictionary after a maximum of two edits. Return all the word in the same order they appear in the queries. Okay, so if you see this example, here we have given queries as word, note, ants, wood, and dictionary has wood, joke, and moat. Okay, so now if you see, if we go, each string in queries, each word by word. So for word, if we see directly, does word exist in dictionary? No, it doesn't exist in dictionary. Now, in word, what all? Since it question clearly says that change any letter in it to any other letter. So in word, we can change word, any character of word to any other character in order to match with any string in the dictionary. And at max that we can uh, edit any character is 2, not more than 2. Okay, so now if you see in word, if we change the character r in word to o, that allows it to equal in the dictionary with wood. Okay, so in here if we change r to o, so here we have this in dictionary with wood. So this is our answer, one of the answer. With one edit we were able to change it to one of the string in dictionary. So we added this into answer, this query word into answer. Now we check for note, if note exists or not. We see note doesn't exist. But in if we change no in note n to j, it will be n j o t e. But now if we change t to k, it will be Joke. So this is there in the dictionary. So there is N and J which need to be changed to T and K. Then it becomes joke, which is there in the dictionary. And this is two edits that we did in this word. That is the maximum that is allowed. So we are good over there. Now for ants, if we make at max two edits, basically for ants, if we try all possible ways, still there won't be any possibility that even after making two edits in this character with any number of any characters, we won't be able to achieve this string in the dictionary. So that doesn't count in our answer. Now wood, we see wood is already there in the dictionary, so that would also add into the answer. So this is our output. Okay, now in this problem, we are going to cover two things. One is the brute force approach. That is what is being asked in the question. That is trying, matching with some word. So some word can be anything from A to Z. So we will try for all the words in the string of length n. For every character, we will try those possibilities. And the edit that is given is maximum. We can do two edits. So we will do that only. And another is the optimal approach, that is using try. So we will solve that as well. Okay. Now let's discuss the brute force approach. So as I already said, trying out all possible edits on each query and check in the dictionary. Okay, so now let's this solve this problem. We'll start with trying all possibilities for this word word. Okay, now let's try all possible combination for this word w in the character, w character in this word. Okay, so for word, what all it can be, I can change this to be aord. I can change this to be bord because we are trying all possibilities, right? All characters that I can change. Then I can change this up to zord. Now for each time I'll see, okay, if this one exists in map or not. Okay, I see it doesn't exist in our map. So what we need to do is, uh, since this doesn't exist in our map, there is two edits that we can do, right? First one is like zero edit. Let's say we search for word itself. Word doesn't exist in map. Now we have to try with one edit. One edit I did. I changed this W to A. I see it still doesn't exist in map. So now what I can do is, for this I can do another edit. So till A I have tried this edit. Now A would remain as it is. I have this word, let's say AORD. Till here, I have tried whatever I could change and whatever I can do. Now for ORD, I would start from here. Okay. Now again for this, what I'll do is for A, for O, now O will be ARD. Then I can make this A to be RD. Then up to AZRD. Okay. So this was the first edit uh, that I made. First edit. This is the second edit that I'm making. Since we cannot change anything after that, so in these I'll see if this exists in map or not. If it doesn't exist, then we can return. Okay, but now changing O we have checked. Now we can try changing R. So what it would be, AOAD, AOBD up to AOZD. Again we will see this doesn't exist in map. Now again we can try for D as well. Okay, so how it would be, AORA, AORB up till AORZ. So for all this also we will check if this exists in map or not. Okay, since it doesn't exist, so after trying all possibilities for this word, it doesn't exist in the map. So for this we have tried two edits. Okay, now I can go back to this O. Okay, because for W I have tried all possibilities, it doesn't exist in map, trying all combinations. Now I can change this WORD to WARD, WBRD, and so on till WZRD. And same thing what we did for AORD, same similar things we will do for all this. Okay, I mean, if we didn't find our word, then we need to do the second edit. So this was the first edit, then we if we still didn't find, we will do the third edit. Similarly we can do for R, and similarly we will do for D. Okay, now when we do for R, okay, so it would be WOAD, WOBD, and then somewhere in between there would be WOOD, and at the end, since we already find this WOOD in the map, okay, with one edit, so we won't further check for this one, that if it already exists in map or not. So from here itself we can return, okay, that okay would exist in the map. This is my answer. I mean, this is one of the query which is going to add into my result. So here this word I was able to convert to wood, so I'll add word into my answer. Okay, so this is the thing that we are actually trying all possibilities, that is all characters modification we are doing word by character, and we are seeing like if it is possible or not. So similarly we can do for note, ands, would, and all that, and accordingly we would be able to fill this array. Okay, now yeah, so now this is how we are going to do it. And so what we did is we first is we put everything in map data structure. Okay, second is we are iterating for all the queries, for all queries. So basically for each string we have to try all the combinations. So this queries is basically, let's say this has length m and this has length n. So from 0 till n m, okay, we are trying. Now for each of them what we are doing is we are checking, uh, let's say this is our, word is queries of I, and we need to first check. So here this is first check that we can do if this word itself exists in map or not. So map exist or something, in this word exist or not. So if it exists, then we can simply return. So this would be zero edit. Now if it doesn't exist, here we can add to our answer and then continue. Okay, if it doesn't exist, then we have to make edit. Okay, so what edit we can do is, for editing we have to iterate in this word, okay, word length. So it would be j is equal to 0 till word dot length, okay, word dot size. And for each character, what we were doing, we were trying all possibilities, right? So we can, store this whatever character is there, you know, into this. So now here we could have stored, um, yeah. So character we are storing in this J. What is the character now? What we'll do for just value, we are trying all possibilities, right? So from A till Z, what we need to do is from A to Z, we will check if this is, this value, let's say it is C, is no already equal to ch. Basically, here if you see, right, this is word has w. Let's say we again, when we explore all this, here we will come to word. So we don't need to again check for word, right? Because it's we have already checked. So this is the character, original character, and this is what we will be changing to. If it is already the same, then we can continue. We don't need to check further. If it is not there, then in that case we need to we need to change it. So what we can change it to? So word of I, sorry, my bad, J would be ch. No, sorry, again would be C. So this is C from A to Z. So all possibilities will try. So if after doing, we so far we have did one edit, right? Now again we can check in map. If in map it exists, then we can add to answer. Okay, add answer, and we can have, some boolean variable here, boolean variable found or not, something like that, to break out from the loop. And we added this to answer. If we didn't found this, then we need to do another, edit. So for that another edit, what we need to do is, again, as I was mentioning, you see, here aord we have explored till A. Okay, now we have to explore the remaining half, ORD. So we can have another loop that would go from k equal to j plus 1 till word dot size. Okay, word dot size. And here, again, we can do this same stuff here. That is this was my first edit. This is my second edit. Same thing we will do here also. And if same thing, we will have this character variable kept, then we would try changing all this A to Z. And if we see, if it, has this ch already, what already existing will continue. If not, then we would change it and check in map if it exists or not. If it doesn't exist, we would return from, we would, if it exists, we will add into answer. If not, then we would return from there. One more thing we need to do at the end is that we have changed this character, right, directly in the word of I. Since it didn't exist at the end, we can, one is we can do is, if we have found the answer, then we can break from this, uh, you know we can basically try the next query. Okay, if we found the answer for this query, we can find the answer for new query. If not, then what we need to do is, this changes that we have did, right, we need to roll back that. That is word of, we need to place this in right positions. We can check that accordingly. Word of j would become, um, here we have stored as ch. Let's say here we might have stored as chh or something. So accordingly, not exactly here, but accordingly we need to roll back as well, whatever it was. Okay, to previous state. If we didn't find, here also we need to roll back somewhere. So this is just the, some sort of pseudocode that I have written. And I will be adding code for this one as well. In case if you want, you can check this. Though this is brute force approach, and if you see, we can discuss this time complexity as well. So what we are doing is, one is we are iterating for all the queries. Let's say queries length we have taken as m. So all queries, for all queries, what we are doing is, this is for all queries. we this one is word dot size, which can be at max, 100. So word size we can, let's say, keep as, um, L, that is the word size. And then we have this another loop that is for 26. So into L into 26. Then we, for second edit, we are again doing the same thing. So it would be again L into 26, because we are doing this same thing over here. So 26. So this M is queries. So queries can also be at max 100. This can also be, length can also be at max 100 if you check the constraint. This is again 100. So altogether it would be, 10 to the power 6 into 26 into 26, whatever it is. I think this would be, something into 10 to the power 8. There's something, you can fill this value, whatever it is. Yeah. So this is time complexity, and I tried this approach. Since it's greater than 10 to the power 8, this won't pass in Leetcode. So yeah, we have to look for the next thing. So now, next approach we can look, and space complexity. If you see, what we have used is, we have used one additional map data structure. So a map will have all the words added into it, and that is of length n. So it would be of n. And here we are checking every time on the map. So we would take an ordered map. So its average, search time is O of 1. So it won't add anything into time complexity. This is about the brute force approach. Now let's discuss about the optimal approach for this problem. So optimal approach is using trie data structure, and whenever we hear something sort of, dictionary, we tend to think, okay, if this can be done using this trie or not, because trie has something related to dictionaries mainly. And one more thing is, this brute force approach that I have tried is, this is similar to word ladder problem. So if you want, you can check that problem as well, where we actually try all possibilities in that question. Now, how we will do this using trie? Okay, so I am hoping that you have some idea about trie data structure, though I would be explaining some part, but might not be, fully depth or something. But yeah, still, with some understanding, you can get this one. Now, one thing is, in trie data structure for word rate. So what our words can have, you might have seen the constraint also. All queries I and dictionary I are composed of lowercase English letters only. And that was the reason only that I was making it from A till Z, small a till small z. So for that reason, since it will be till A to Z only, so our trie will, there will be one node which will be starting from index 0 till 25. Basically, it will have, it would be of size 26. This is how the trie is, and every this node has address to its child, I can say, child, basically next node where it points to. So this is how it is. So this will also, this will point to another node, and this will have again same thing. Okay, similarly same thing. So and for all of this, okay, for all of this, there is this array containing 26 nodes, basically address for those 26 childrens. Okay, so, and one more thing, that in our case that we need to consider is, uh, we this is normally how try is, but in our case we also need to consider when we how we would solve this problem is, first is we'll put this dictionary into trie data structure. So this is our dictionary. starting from word, joke, and mode. So we would put this into this try. Okay, so how would that would be? Okay, so would start so what does this 0 means? Like this is A, B, C, 25 is Z, right? So somewhere here it would be W as well. So for W, what we can do is while putting this character, um, so I'll just show a little piece of code over here what we actually are doing. Yeah, so if you see, this is our node that was I was talking about, and node has basically this list of children's that is of size 26, initially initialized to null because it stores the address. So initially it don't have any children. When we create a node, there is no children, so it is all null. And it also tells in our scenario, in our case, we need to know if this is the end of the word or not. Okay, and initially when we create a node, we will just make it okay false, this is not an end word. Now this is one method which tells it has child or not. So here, as initially I told, right, we would have this as all null. Okay, null, null, and so hash child, what it does is for any character, it goes and check if it has this or not. So I would just first add any word and then we can discuss. So let's discuss. Let's put word into this try. So sorry, wood is there, no? Let's put wood. So it would be somewhere from here 0 till 25, and here somewhere it is W. Okay, so W has this. So for W will now point to this. So W will have list of again same thing from 0 to 25, and W, then from W it will point to O. From O it will again point to O, next O. From O it would point to a D. Okay, so and from D it points to null because every time when we create a new node, right, so it has all its children pointed as null. Now for D, this particular node which has this list where all of these are initially marked as null, there is one more point in every node we are storing, that is here, if you see, is word end. So if you see, this was not our word end, right? Basically we don't have any word that ends with nothing, like empty string. Then what here it means is this, what it stores is it stores address for this W, right? So we don't have anything ending with W. So this is also false. Okay, this was also false. Similarly, we have nothing ending with this 0. So this will also have false. This we have nothing ending with this 0. So this will be false. Now we have this D. So D has this children's, but we know that at this D there is a one word that ends with this D, right? So is end word. So that is true because this path which we have came through W O O D, this is a word, right? Wood, that is in our dictionary. So this is how we would be placing all our words into the dictionary. Okay, so this is first step, put dictionary in try data structure. So this is done. Similarly, we'll add for joke mode as well. So how would it would be? So J would be somewhere here. Okay, so J would have its another address and this children. So it would have its children where it would be O. From O it would be you know K. From K it would be E, like that. And from E, here is end word would be true. Okay, is end word would be true. That joke is a word. Okay. So every accordingly all these characters next move. So here if we have somewhere somewhere here move M, so M will have its children's, and accordingly we will create it. Okay, so this was the first part that we did. Now check for each query character by character recursively. Okay, so this is the queries that we have given, and now we need to check each of these queries character by character, and recursively we will check. In recursively, how I'll tell you how we need to check such that it can if any edit is needed, it should be doing at max 2 edit. Okay, and same thing if it exists in the dictionary, this character, since we are checking character by character, if it exists in the dictionary, then what we need to do is uh, we check for the next word. Okay, sorry, next character in that string. If it doesn't exist, we will use our edits. Okay, we have 2 edits allowed, so we will use 1 edit and then check for next character. And if we are out of edits, then we can return false. Okay, that no further edits possible. So now let's check for word. Okay, I'll just do a quick dry run, so maybe I can create a cleaner try where we have you know uh, this this is W, then this is O, then this is O, and then this is D, and it has this null. Okay, this array and end word is true. Now for let's one first query is wood. Okay, and similarly here we would have joke and here mode. So it would be O K and then E and then null. Okay, and then it would be M O A and then T. Now let's check for wood. So when we start with start checking, so what we was doing, what we were doing there was we were checking for all the possibilities in the dictionary, right? All the possible characters for that query. Basically in wood we were changing W to everything. By everything, what I mean is from A to Z, right? But do we really need to do this? That is the benefit of using trie data structure. One is first I'll check if this character word exists here or not. Okay. So this W has child or not. So here we see W has childrens. Okay. Which means W exists. Now with W, what is the next character? That is O. For O, I see O has children or not. O has children. So for O, now we see next O. Sorry, one second. My bad. Query is word, not wood. But yeah, I mean, if we just query for wood as well, we can see that okay, it has next children. Then D, we see D's has next children. So we know that this is okay. This is in our hand. Now, our actual query is word. Okay, we see word. Word W has children or not. Yes, it has a children. So okay, now we get to this children. Now our next character, what it is? It is O. So we check, okay, here O has children or not. O has children. Now we came our next, I mean, to the children, and what we need to check next is that R. So R we see here somewhere, right? O here it would be R as well. Now we see that R has children or not. So R has no children, right? Initially everything is pointing to null as I told. Because this was while, I mean, how this trie looks is we have added all our dictionary into this array. Now R doesn't exist, right? So R basically R doesn't have the children. So how what we would do now? Here we will use our edit. Okay, we have two edits allowed, so we will use one of the edit. So I can keep something like, used edits. Initially we have not used anything so far, so it's 0. Now we will use one edit. So what does edit means? That in we would change this R to whatever possible. Now what is possible? Here, for in this case, it is just wood, right? Now let's say for example, it here it might be something like, WOA and then D, right? So in that case, this can also be possibility, right? That for I mean R, I need to change it to A instead of O. Let's say O, you know, I mean this can be a possibility that okay, for this A we need to change this R to A, and further instead of D, let's take it A as well. So instead of D, we see there is no D, we have to change this to A or whatever. Since there is two edits allowed, so we would be able to do this. So for that reason, we need to whatever is there, right? So this is of 26 length. So we would try all of this, okay? All of this which has children. Basically changing this R to everything which has children, okay? And we won't actually change it. We will just assume that okay, this is changed, and we would continue with their children. So one possibility would be we will continue with A and their children. Another possibility would be we would continue with 0 and further their children to map our thing. Since this A doesn't exist, so I won't keep it for now. With 0 we will continue. So for 0, sorry, my bad. For O we will see. So for R we have used one edit, we have considered it as O. Now for O, I see if it has next or not. It has next, and that points to it has next. Now what is our next character over here? So it is D. So I see if D has next or not. So D has next, uh, but D has next, and D is the end word, right? So this is the end character. So for end character, we need to check if this is word end or not. Okay, and since this was end character, is word end was true, right? So here we can say that okay, this exists in our try. So yeah, this is with one edit we were able to do this. So I have mostly explained like how it works and try as well, and how we are recursively doing this. So I can just write code step by step. So one part was this one, which we already discussed, how we are having this try, and we are initially creating this children, and this is actually every node, and every node has 26 children initially, each pointing to null, and is word end is also false, and it has children method, add children method, get child method, and mark end. These are the methods which are required. Now we would uh, write our code. I hope you understood the explanation. Now we have our node, but to start with we need to create a new node, right? So we would create a node. So this is our root node that we have created for this try, and then for inserting we need to have this method. So this is again what we usually do in try, how we insert any string into this try. So this is how it is. uh, we basically for inserting this word we need to create a node, okay? And because I mean I mean, we have this root created. Now we need, so this word we need to add, right? So this will be added character by character. So we need to start from here, right? And then this is our root node. Okay. So we have to add character by character. So we need another, node to iterate over this try. So yeah, we will keep this as root. Just for iterating, we need this. Now for I equal to 0 till, or maybe let's keep it like, so for all characters in this word, okay, we first need to check if it has children or not. Okay, if it doesn't have any children, we need to do certain things. I would come to that. If it already has children, okay, uh, so already has children means, um, okay, maybe I'll just come with this part first. So if there is no children, right, for this node, for this particular character, okay, so we have our word as word. Initially, while inserting for this first character, there was no children, right? So what we would do is I would first check node node has children or not for this character. If it doesn't have, which means it is equal to null, then in that case we need to add children. Okay, so adding the children, adding this children, basically adding this character w, and we need to create a new node as well. So new, so here if you see, when we initially created, so it was all null, right? Initially it was null. Now we came to w, and so we need to tell, right, which character we need to insert children for, and we need to pass the children as well, that okay, this is where you need to put this children. So w will point to this one. So this one is basically another node, right? So this is another node. So we are passing a new node that okay, at this character add this children. Okay, so we are adding a child to that. If this was the case when we have when we don't have children for this character, now there could be possibility that there is already a children for that node. Okay, so in that case, what we need to do, we simply need to move our pointer to next one. Okay, so what it would be, node equal to node get child, ch. Okay, and get child will give me the next child. For example, when we have this wood, right, would have added. Now next word that I was adding was w o a and a, right? So when I came here a w, so it already existed, so I don't need to create its children because it already existed. Now I came to o, so for o also I see it's already, it has already this children, this as this entire thing as children. Okay, so I don't need to create. Now when I came here, I see like, okay, does a have children? No. So for a I need to create this children. Okay, so that is what we are doing. And since it already had this children, we need to move our pointer, right, node pointer to come here and iterate further. So that is what we are doing here. Okay, get child, and then this is node will be moving there. Now node equal to, sorry, since we have added our word, So we can mark this as end word. Okay, so at the end, our node would have moved to, this children, and there we can mark that as end word. That one word end with this, uh, this D. There is a one that ends with this D. So this is the method to mark end. This is about the insert method. Now, now our main thing starts. That is first main code starts here. What it says is we have this, result, this vector string result, and for first thing was we need to insert our, you know, all the dictionary words into try. So, same thing we can do is the insert method that we have created here, right? So we can simply use that all words starting from 0 till n insert method we can call, and then we can pass this dictionary of I. Okay, so we have passed this dictionary and we have inserted all the words in the try. Now next thing that we need to do is we need to check for each query. Okay, so for this I can say query in queries. Again, this is a loop. I mean, you can just write it. Here what we will check is if, you know, this method we will create that if can match within two edits. This is the method that we need to call if this can match within two edits or not. And this will have certain parameters. I'll come to that. If it can, this is a Boolean method that will create. If this can match within two edits, then we can add our result dot pushback this query. Okay, because we were able to match within two edit word from a dictionary. So we will add this query into our answer, and then we can return result. Okay, so what all things we need to pass here, I'll just tell that, and we can discuss this method as well. Now, as we were dry running. So one is we were matching character by character, right? So we need to pass this query. So query. Then, as I told that we would be matching this word character by character and doing it recursively, right? So for recursion, we need to start with the first character, right? Where first character is basically index 0, so we would pass it as 0. That is my index. And I was also for every query there was two maximum count that was allowed, right? But initially how many count we would have used? We have not used anything, so I'll pass count as 0. Now since where this query we need to check is we have created this try, and in try we need to check for all this query, right? So I would pass the root for this query. Okay, so root for this try data structure that we have created. Now I can just write this method, that this is a Boolean method. This is our third part. We can say can match within two edits. Okay, so it will have our word, it will have the index, it will have edits used, and then it will have our node. Okay, so first thing that we need to check here is if the edits that we have used, okay, is greater than 2. Okay, if we have used edits that is greater than 0, then it is not allowed, right? So we can return false. Or the node that we are exploring, right? For example, uh, here let's say dictionary has this word WOOD, but let's say our word that we are querying is WOODE, right? Now, when it will check for D here, after D, it has this null, right? Every uh, this node, next node, it has all null. For E, it has no children. So there here it might be somewhere E. E don't have any children, right? So for that reason, if while iterating, if we came this node to be null, okay, is equal to null. So we can return false. Else, if this index that we are exploring, it is equal to word dot size. So which means we were exploring this wood. Okay, for the query wood, we came to this value where this is the next index where value is n. So here I need to check if this is end word or not, because we cannot explore further. So here we will check. So we can simply call this node is end word or not, because if you see this D, right, D is pointing to this array. It's little, yeah, D was pointing to this array, you can say. So here it was all null, 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 but this boolean value we have, right, is true. So there we need to check. Okay, I mean next pointer I would have passed to this thing which is null, and there it has is end word or not, is word end. So whatever it returns, if it is true, it will return true. If not, then we will return false. So this is our another boundary check that we need to do. Now we can have, character index this int value as this word of index minus a. It will just give me, index, which index I have to check for. This is the character index. Now, first case we have to explore where we actually don't need to do any edit for that particular character, since we are doing character by character. So this is no edit case if node child for this index, this character index, this is character index. If this is a child, this has a child, basically you can keep it as not equal to null. So if this which means this character, I have found this character, I have to explore to find the next character. So for that again we will have this function call. So this is nothing but I'll mark it as f, this function call, which would be again I would pass this word, since I have found answer for my current index, so I can explore, index plus one, next index I need to explore. Edits use, this is already, we already have this word existing over there, so we don't need any update on our edits. It is, we don't have used any edits, so it would remain same. And we need to explore to the next children, since it has this children, so now we need to explore the children. So node children for this character index. Okay, now if we call this function, and if it gave us a value as true, right, then we can return true. So this was no edit case where we didn't need to do any edit. Now there is the edit case if we basically it didn't had any children, right? So what we need to do use our edit. So for using edit, one thing is we need to have first check is if edits used need to be less than 2, then only we can use our edits, right? If it is, then we need to explore for all these characters. So I can take it as c is equal to 0 till c less than 26. And if it is our initial character index, that is this one, so we can simply, index, then we don't need to check because this is already that, we have checked. So yeah, if otherwise, what we need to do is we need to check if again this children has, you know, this index C as not null. Basically, it has children. If that is the case, then we can do this same thing. Same thing that we will call this function with the word, obviously. Index, since we are using our edit, so we can pass pass to the next index. Edit, we are using one, so it will be, edits plus one. And we need to move to our next children, so it would be node of C. And if we did this, thing, and we were able to, match within two edits, then we can return true from here. If not, after trying all this, I can return false, that it was not possible. Yeah, so this is code for this approach, and we can now discuss the time complexity. Okay, so first is our main method is over here. If you see, first thing is we are inserting this into our dictionary, and inserting is, one insert can take, uh, this word length size, so word length time, one insert, and one word length in the constraint it is given, it is 100. So worst case it would be, 100 for each insert. And for we are doing for this dictionary has length, let's say n, so n into 100. This is, let's say L was the size that we took, right? So n into L, n into L is this one. Now here if you see, for each query I number of queries I marked as m. Now for each query we are having this can match within two edits. So now let's discuss how much time this is taking. So here what we are doing is, for first is if it without edit it's possible, then we are doing it. If we need to use edit, then we are having this loop, and for that loop we are changing it to, 25 characters. The existing one we are not changing. And since we were allowed two edits, which means that for one edit we would explore 25 possibilities, right? Then for another edit we would use another 25 possibilities. But let's say in between if we found anything, we would return. So this is worst case that I'm discussing, right? So 25 possibilities, then 25 possibilities, because there is two edits at max we can do. And for both of them we need to, go over word length. So it would be word length, let's say L into L, and then we are doing this for our queries. So this is the worst case, or I can write it simply like, uh, q into L square into 25 into 25, something like this. This is the worst case scenario. And space complexity, if we see, so space complexity is, um, for this try, each will have 26 uh, 26 length, and each 26 will have further 26, and word length can be max 100, so it will be 26 into 100 for try data structure. Yeah, so this is space and time complexity for this approach. I hope you like this video. Thank you for watching. That's all for this problem. I'll be adding GitHub link for my code in description below. Stay tuned for next video. Thank you.